go a little bit more physics for this video. I'm also going to be applying it to the universe, but for now, I'm going to be discussing torque. What exactly is it for those of my followers that are not completely physics literate, but I want to cover that right now because I think it's very important. And I have a video that was just floating around my Instagram recently of me doing pirouettes at 10 o'clock at night, and I wanted to cover what exactly happens when a ballerina does a pirouette. So in that video, I actually I was just in my socks, but otherwise there are ballerinas that will go on point or in point. And this is a point slipper. It actually has a carved out piece of wood right here that has a hard surface so that the ballerina can be lifted and all the weight can be distributed in this area of the point shoe. So torque is just the twisting force that causes the rotation. So when you look and you break it down into the equation, you have a little written here. T equals F times R times sine of theta. Okay, so without all that, I'll just explain what exactly that means. T is torque, F is the force, and the force is what lifts the ballerina from being on a plane going this way into this plane. So this is considered a linear plane, and this is a linear plane. And you're multiplying that by the actual linear plane. So you're multiplying the force by the location and the distance in which the ballerina is from the point here to the top of her head. And then you multiply that by sine theta, which is just the angle going from here to here. The ballerina, in order to have a complete 360 turn, needs to have the correct amount of rotation of axis, which is the point that's right here, which causes her to turn. In order to find that, you have to, again, get the correct amount of force to lift her up and to spin. Now, let's compare torque on the universe scale. So we'll take Earth, for instance. I blew up this balloon. It's starting to shrink a little bit, but let's just pretend that this is Earth. So I drew a line right where the equator would be, and it looks like it's a funny shape, and that's because the Earth is not actually a sphere. It's considered to be an oblate spheroid, and that's because it bulges at the equator, so it's kind of like squishy like that, and it bulges at the equator, which would be right around here. This is actually caused by tidal forces from the sun and the moon. It actually pulls on the equator of the Earth. And this causes the Earth to precess. And to precess just means that the axis of rotation changes. Now, if you guys remember, the axis of rotation, like with the ballerina, is right here. It's what causes the twist and the torque of the turn. The axis of rotation with the Earth changes, so this is why we say that the Earth wobbles, and that's just because with the forces being acted on it, like force, which is what I was saying is in the equation for torque, it acts on the Earth and it causes it to wobble, so it causes the axis of rotation to change over time. And that's because it's constantly being pulled by the sun and by the moon, so that our Earth is always doing this. That's what I'm going to conclude on as far as what exactly torque is and how torque it works in our universe. I didn't figure I would go into details as far as how torque works when it comes to like automobiles and other stuff like that, because I want to try and compare it to more of a universe scale because I talk about the cosmos. So I'm going to end on the note about the NASA Transition Authorization Act. So NASA's new bill was just signed by, so of course, the House of Representatives, the Senate, Congress, and the White House just signed it. So very exciting about that. There is a bit of controversy about it. Everybody's arguing, but there was an increase in the budget, which was really great. NASA was not proposing it, but there was an increase in the budget, which was really nice. What's great is like all, like I said, like all that money is going back to the people. It's going back to the jobs. It's going back to the research. It's going to the communities. It's going to building more technology in like hospitals and medical facilities. On top of which, it's also about, sending like people to other like planets in our solar system and exploring like Europa, exploring things, beyond our own solar system, and sending out like the new James Webb Telescope. And so it's very important, and I'm very happy about that. And my article that I wrote for A+ about my experience going to Congress should be published in about a week or so, so definitely keep a lookout for that. And I will be posting it also on the Astra Athens website, which is on my blog, so I will do a quick little thing about that too. Thank you again so much for watching, guys. I hope you found this to be fun and useful, and be sure to keep learning. I'll talk to you guys soon. Bye.